ggplot is an incredibly powerful package that can create beautiful charts. And if you've been wanting to learn ggplot, here's your chance. I've created tons of charts with ggplot, and today I'm going to put in all of my knowledge into one ultimate getting started guide. And if at some point you want to learn more about ggplot and how to use it to create really insightful charts, then I've got a video course on that. If you're interested, you can check out the description. But today we're just getting started with the basic things of how ggplot works and how we can use it. And the first thing we need to do is to open up a new quarto document where we create a new R code chunk, and in there we are going to load the tidyverse, which will also load ggplot2. And then, just like an artist, we grab an empty canvas. In our case, this means that we're typing out ggplot, and if we call this, we will get, well, an empty canvas. Now it's time to put geometric objects on top of this to form a chart. This is basically how ggplot works. It stacks layers on top of each other. So here we are going to add a point layer, and this is why we add a geom point layer to our initial ggplot. And again, if we execute this, nothing is happening, because how the hell should ggplot know what it is supposed to plot? Of course, we need to specify the things that we want to plot. For example, for points, you will need to specify the x and y coordinates. This means that geom point will need additional information. In this case, we need a mapping. And inside of this mapping, we will have to use the AES function, which I will explain in a second. But inside of this, we can just specify the x coordinates using a vector of some numbers. And for the y coordinate, we can do the exact same thing. And once we execute this, we'll get a chart where we have 4 points, where each of those points is plotted exactly at the coordinates that we specified. Now, I am certain that you are wondering what the hell is doing AES. What's the point of this? And this is the typical thing that everyone is wondering at the beginning. So to demonstrate what this does, let us add another aesthetic by specifying the color of the points. By the logic that we've just learned, we could just add another aesthetic, in this case we say color, and set this equal to a vector of colors, in this case these 4 colors here. But once we execute this, it doesn't look right. Notice how the colors are very much different from the one that we see in our console, and also we have a legend now in our chart. That's not really what we signed up for. Now check out what happens if I take this code here, and instead of putting this into the AES, I put it outside of the AES. Now if I re-render this, then everything works as I intended it to. Now the points have the exact color that I specified. This one here is red, this one here is blue, these two are green. It's probably kind of hard to tell because the points are really small, but in any case it worked and we don't have a legend anymore. So obviously we get completely different behavior if we put something inside of the AES call or outside of it. We have seen that if we put something inside of the AES call, we don't specify things ourselves. Basically we say, ggplot, here's my data, pretty please do a useful color thingy with that. And ggplot is like, okay, I guess I can take the names that you gave me and make a color legend out of that. And when I do, I will assign a unique color to each of those names you gave me. That's kind of what ggplot is thinking then, but also it will think to itself, boy, I hope there are no real color names inside of the names, because I don't know how to handle this at this point. And this is really what's happening here. ggplot just takes what you gave it. It doesn't know that what you gave it are actual colors. It just interprets it as some names. And then for each name it assigns a color and then sets the corresponding point to that color. And outside of the AES call, things are different. There we specify things ourselves. There we basically say, listen up ggplot, for each of the points here are some colors, you better use them just like I specified them. And then ggplot will just do what you say. So that's the reason why things behave differently depending on whether you put things into the AES or outside. But I can already hear you say, hold on guy, we did stick the x and y coordinates into the AES. Why is that? Clearly that's something that's supposed to be taken as is and should therefore be outside of the AES. To which I reply, that's a great observation, young Padawan, but you're wrong. You see, it's easy to think that the coordinates are fixed, but really ggplot has to do quite some calculations to figure out where to place them on the canvas. First, it has to figure out what the range of the coordinates are. And then it has to figure out where to place each point according to the current maximum and minimum values of the x and y axis. And that's no small feat. Behind the scenes, ggplot does this by computing so-called scales that translate data to visual properties. That's a lot of work, so let's be thankful that we don't have to deal with that. In fact, ggplot is so nice that it even hides the stuff it calculates for us. As I've just said, it uses scales to do all the calculations for the things that you use in the mapping. But technically you will also have to add those scales to your ggplot. But thankfully, we don't have to add these scales if we don't want to change things later on, because by default, ggplot will also use some pretty good default settings. And that is why we can just leave those parts out if we don't want to have them. Now, this was a lot of information. Let's put this to a test next. We first create a new code chunk, and in there we create a new variable. In this case, this will just be the penguins variable, which is just the data from the Parma penguins package. It kind of looks like this. If you haven't seen it, it is just a nice data set. It has a couple of nice measurements like bill length or bill depth from penguins. And with that, we can just take our code from before and replace our X and Y coordinates of points that we plotted with things from the penguins dataset. For example, we could use some column from the penguins dataset. In this case, I will choose the body mass column. And similarly, we have to choose a different column for the Y-axis. Here, let's just use the flipper length. Of course, there are way more points in this than these 4 colors here, so for now we can just remove those and see what ggplot will give us. Nice, it has created 1 point for all of the things that are inside of our penguins dataset, namely in the column body mass and flipper length. Basically, it took those vectors that we have here. This is one of those vectors and does the same thing for the other one, and then sticks this into the X and Y coordinates of geom point. Now, this chart isn't that pretty yet because it's plain black and white. Maybe we want to make the points at least into this blue, Dodger blue 4 color. So this begs the question, do we have to create a vector that has Dodger blue in all of its components just to make sure that for each of the points that we have here, I don't know, for the 300 something entries, do we need a vector that has Dodger blue inside of each entry? Thankfully not. ggplot is so good that if you specify only one value, then it will just take this value for all of the things that you've specified in your mapping. And that way, if you execute this, you will get blue points. At this point, you may want to also make the points a little bit larger, and this works via the size aesthetic. There you can just set the size to some larger number and you will get larger points. But now they are overlapping quite a lot. So we could use another aesthetic, namely the alpha aesthetic, and set this to something which is lower than 1, which will make it 50% transparent. And that way you can see more of the points even if they overlap. Now, having all the points use the same color isn't that informative. We can already see in this chart that the penguins which are further to the right on this axis here, so which are heavier, they also tend to have a longer flipper. But maybe there's also some difference between species. Remember, our data set also has a column called species in which we have different penguin species recorded. Maybe it would be good if we can colorize each point according to the species value it has inside of this column. And luckily, we already have all of the tools we need to make this happen. What we want to do here is to, for each of those entries, assign a different color. We have already seen that before, right? Remember when we put color inside of the AES? This was exactly what happened. And following the explanations we've had before, this is exactly what we should do here. Just give ggplot some data and let it figure out the colors on its own. So let's do that. Let's take this color here. We have to remove the hard-coded color value and instead use the color inside of the aesthetic. And there we use the penguins dataset again, but in this case we use the species column. Again, this may feel very weird because what we actually do here is we do not pass colors to this color aesthetic here inside of the AES. What we do pass here are values or text called Gen2 or Ginstrap or Adderley. These are hardly color names. So at first it can feel very weird if you stick this into the part where you say use colors like this. But the thing here is that we don't want to specify the colors ourselves. We want to let ggplot do the calculations for us. And in fact, we see that if we execute this, it really does the right thing. For each species, we have a differently colored circle now, which is kind of cool. It was very easy to make that. And we can see now that it appears that the Gen 2 penguins are both heavier and have longer flippers compared to the other 2 species here. That's kind of a neat insight, and we have generated all of this from a couple of lines of ggplot code. Oh, and this reminds me, if you like this video, don't forget to hit the like button. This video was actually a ton of work, and I appreciate a like if you enjoyed this video. One thing that is bothering me here is that the points are maybe a bit too transparent. Maybe we should change this to 7.5 now, and now the colors are a bit easier to see perhaps. And another thing that is bothering me here is that we repeat our code a lot of times. We always write penguins dollar here and here again. And the really cool thing is we don't have to do that. We can just stick this into the data argument. So let's just put the penguins in there. And then we actually don't need those penguins $signs anymore. We can just remove them and the code works just the same. And what's even better, we get nicer labels here on the X and Y axis and also on the legend here because it doesn't use those long names from before. Speaking about nicer labels, in ggplot we can do a lot of things that we want to do by adding another layers on top of what we already have. And in this case, we can add another layer called the labs layer, which is responsible for all of the labels. Shocking, I know, who would have thought that given the name, but that's just what it is. And the nice thing about this function is that it's very easy to handle. For each aesthetic that you want to rename, you just say the aesthetic is equal to, and then pass in the name that you want to use. And then just do this for all of the things that you want to change, and then you get nicer labels. But the labs layer isn't just restricted to aesthetics. It can also change different labels like the title, the subtitle, or the caption. You can put all of this into the labs function, and then your chart will also include that. Another set of really useful layers are the theme layers. And one of those is in particular very useful because it's just one line of code like add theme minimal, and you will change the overall look of your chart. And another really nice thing about this layer is that you can increase your base size by just putting in another base size here, and that way you get nicer or at least larger font. And you probably shouldn't underestimate how important that is. It doesn't really matter how nice your chart is. If no one can read a thing, it will not matter at all. So keep that in mind, make sure that your font is large enough. It really is easy to just crank up the font size like this one change in this one theme minimal layer. Of course, there are a lot more theme changes that you could use, and all of them happen in the theme layer. If you look inside of the documentation of this and scroll down, you will see that it has a lot of argument names. It can style basically everything that you can think of, all within this one layer. Today I won't show you how you can change all of the theme stuff, but I will at least show you the system behind it, how it works, and then you can play around with these things yourself. Really, there are two types of arguments inside of the theme layer. The first argument type is really easy. There you just have to take some argument that you maybe got from the help page, like plot title position. You could scroll all the way down to find it. It should be right about here, plot title position, and there it will tell you that it's responsible for the alignment of the plot and subtitle. And there is another one for the caption as well. So this one is a very easy one because you just have to set it to some value like plot. It's described here. And then you can do the same thing with the caption, and if you execute this code, you will see how the code moves. Another important argument in that category is the legend position argument. There you just have to specify some value like top, bottom, left, right, or none, and then you will see that your legend moves. So these were the easy type of arguments, but there is another type that is a little bit more complicated. For example, if you wanted to change the plot title, you could use the plot title argument, but this one doesn't just take a value, it actually needs a text element. What this means is that you need to use a helper function to generate such a text element. And the name for this helper function is very easy, it's element text. Basically, for all kinds of geometric objects, you can look into the documentation of, for example, element text. You will see that there are also other elements like element rectangles, element lines, element text, and all of these have pretty straightforward arguments like for the element text, what's the font family, what's the color, what's the size, or for the element rect, what's the fill color, what's the border color. Basically, it's pretty self-explanatory what these arguments are supposed to do, but you have to keep in mind that a lot of arguments will actually want you to use such a helper function that generates an element according to how you need it. And in this case, I have seen in the theme layer that if I look into plot.title, it's here. And if I go down here, it will actually say that it needs an element text. All right, so that's how I knew how to use plot title by using also element text. And then if I execute this, nothing changes. It will just use the default values it has used before, but now I can change some arguments inside of element text, like increasing the size, making it bold, or setting this to red. So once you understand this system, it's pretty easy. Let's do another one. For example, we could change the plot background, and this one will need a rectangular element. And inside of that, you could, for example, change the fill color. That's pretty ugly, but that's what we're going for here. We could also change the color here. You will not see a difference in this kind of plot, or maybe you could. If you look very closely, you will see that the border color is kind of black now. But if you increase the line width, you can actually see this much better. So cool, that's how the theme layer works at its core, and that's how you can modify all of the theme stuff. And the way to learn all of this is to just play around with it by making something really ugly like I did here. You see, if you try to make something pretty, it will get really frustrating and really hard because you probably don't have any idea what's good here, what do I need to do here. Instead, you should just go for something very ugly and try to make that happen. And it's actually not as easy as you think. It is a great learning exercise to just create something hideous here and play around with all of those arguments inside of the theme layer. And as I said, behind the scenes, ggplot uses so-called scale layers, and you could do the exact same thing that you do with theme and just throw it in there, check out what the arguments are, check out what the description of those arguments are, and then throw in some stuff like, I don't know, setting the limits to 3000 to 8000. You will see I have added way more space over here. You could try to change the break labels. Now you only have a couple of those here. And you could even set those labels to something ridiculous. It doesn't matter what hideous thing you create here, as long as you try to make something happen using the function that ggplot has. And once you know how to do all of these things, feel free to check out my video course where I can show you how to make this look very nice. But if you're just learning, just getting started, feel free to just go wild and do something hideous here to create a very ugly chart. All right, now let's switch gears a little bit and try to create a completely new chart. So let's throw in a new code chunk, and in there we use a new basic canvas. And now let us add a new geom layer. In this case, we use geom_bar. And in there, I specify my data argument and set it to the penguins again. And now one thing I do is I specify my mapping again, but I only specify one aesthetic here. And when I execute this, it actually works and I get a bar chart. So I guess this is what geom_bar does. And this bar chart tells us how many penguins of the different species are inside of our dataset. Now, the fact that this works is pretty wild if you think about it. You are probably wondering what the heck is going on here. We have only specified one aesthetic, and also what kind of geometric object is bar. You probably at this point thought we'll always add stuff like geom point or a geom line or whatever, some real geometric objects, and not something like bar on top of that. And crucially, our data set, if you look at this, you will notice that none of this data contains the information that we actually plotted here. Think about this. We see now that there are about 150 Adelie penguins in this data set, but there is no entry in here that says species Adelie number 150. You just won't find this. But what we have here is a lot of rows with Adelie in it, and it appears that there are at least 150 rows with Adelie inside of it. And this is what geom_bar does. Not only does it plot something, it seems to also do some statistical transformation to get the correct value from the initial data set and then plot the correct values that it just computed. And the reason why this is happening becomes apparent if you look at the documentation of geom_bar, because in there you will see that stat is set to count. Here stat means statistical transformation, and this means that the statistical transformation that is performed is a counting operation. Basically, what this does is it just takes your data set and counts the species, and then you would get a data set that looks like this, and then it would plot this using some other geometric objects. So just for the sake of understanding this a little bit better, let us actually save this data set into a variable. Let's call this counted penguins. Save this in here. You might be under the impression that now, since you've counted this, you could just take your counted data set and stick this into the data, and then it would be basically the same thing, and we can actually check that if this is happening. So let's execute this, and we get a plot that doesn't look quite right. And if you think about this, the reason why this is happening is because geom_bar still tries to count the species that you have in your data set, and you see that in your data set you have each species one time each. geom_bar doesn't even look at this data here and tries to figure out what's the value here. It just thinks that, okay, there's one Adelie, one Chinstrut, one Gen2, guess that's all the data, and then it throws these three equally sized columns in there. So you might be inclined to say, you know what, then let's just map this to the X aesthetic. Let's just force it to use this n column here to actually plot the thing that we want. And if we execute this, we will actually get an error because it says that stat count must only have an X or a Y aesthetic. And the reason for that is basically that geom_bar just can't stop counting. Its statistical transformation is set to count. and therefore it will always try to count. So at this point you might say, well, then just tell geom to not do a statistical transformation, just stop that. And this is a very natural thing to ask, but it's just not what is possible within ggplot. You see, in the so-called grammar of graphics, which is what GG stands for, there is always a statistical transformation in all layers that you use. But now you're probably thinking, this cannot be right. Here at the previous charts, we haven't used any statistical transformations before. How is that happening? But the truth is, we actually did use statistical transformations. If you look at the documentation of geom, you will see that there is a stat argument, but it's just set to identity. This is basically the most boring statistical transformation that you can think of. It just doesn't do anything. You see, just like Patrick Star takes bikini bottom and pushes it somewhere else, this statistical transformation takes the data and pushes it somewhere else. Nothing else changes in between.
We should take bikini bottom and push it somewhere else.
So to fix our problem with our bar chart, we can actually force geom to use a statistical transformation that does nothing by setting this to identity. And now we can actually execute this and we get the chart that we want. Don't be alarmed if you find all of this very confusing. It is like this for everyone. But sometimes it's just really helpful to let ggplot do some calculations for you. For example, we could do a similar thing by taking a base canvas here and then using this stat bin layer, which I will explain in a second. And then just like before, we specify our data set and our mapping where we only specify one aesthetic, in this case the body mass of the penguins, and that way we get a nice histogram. Basically what this does, if you've never seen this before, is it takes the range of your data, splits this into equally sized bins, and then counts how many data points fall into each bin. And for each of those counts, it will then generate a bar chart like you see here. So you're probably wondering, why are we using this stat bin thingy? Basically, this stat bin thingy here is the natural companion to geom. You see, just like any geom layer needs a statistical transformation, every statistical transformation needs a geometric object. Super romantic, I know. Basically, you could generate the same chart by using the companion from this layer. In this case, it's geom. And then in the stat layer, you just use the bin statistic. And then you see that you get the same chart here. Let me just throw in some other chart in between so that you see that this chart actually generates the same thing. So really there is a connection between geometric layer and statistical layer. You can achieve the exact same things using either a geom layer with a different statistic or a statistic layer using a different geom. And really the only reason why I'm showing you this is because some people like to make it very obvious that they use some statistical transformation. But more importantly, you might actually run into these kind of layers in the wild when you look at some code from, say, Stack Overflow. And I don't want you to be confused and say, what the heck is going on? I only know geom layers. Why is there a stat now? If that happens to you, calm down. Remember, for every geom, there is a stat equivalent. For example, and I show more examples of this on the blog post that underlies this video, and you will find the link of that in the description. But just to see one example, you could, for example, change the geometric object here and not use the bars that StatBin uses by default and use, say, point instead. And that way, instead of bars, you get points that correspond to the same values from before. Similarly, you could use line as well, because there's also a geom line. We haven't covered it yet, but I probably guess you can imagine that if there's geom point, there's also something like geom line. Here you could use that and it will actually connect those points instead of plotting the points. Again, this is just a nice thing to keep in mind in case you run into these things on your own when you're looking for stuff. Here, let's just reset this to bar. And really, in a scenario like this where I want to have a histogram, you probably won't even have to use these layers here. You could just use this part here. You don't have to worry about the statistics, and instead of geom, use geom histogram. It does the exact same thing, but is probably a little bit easier to operate. Similarly, you could generate this bar chart that we had before without having to worry about the statistic by, well, removing the statistic and then using the geom call layer. Will give you again the exact same thing. Okay, so the last couple of things were a little bit technical. I feel like this background knowledge is good to have, but now it's time to do something more practical again. For starters, let us make our bar chart a little bit nicer here. For example, one thing I like to do is to add labels like the exact number that each bar represents into each bar chart. And we can easily make this happen by adding text on top of our layers. And the way ggplot works lets us modify the layers that we currently have and add other layers to this. In this case, we want to add labels, so we might have to do something like geom text here. And it's really good that we have our data set that contains the exact numbers, because now we can use this exact same data set to use this as the labels. All right, so let's just copy this part here, because this layer should use the exact same data set. And then we specify the aesthetics again. And now we have to specify the X and Y coordinates of the labels so that ggplot knows where to put things. And of course, we need to also specify a text label that we actually want to use. In this case, I want to have labels at the top of my bars. This means the Y coordinates is the same as the bar itself. It's this Gen2, chinstrap, and Adderley. By the way, ggplot will interpret this as 1, 2, 3 behind the scenes. So the coordinates are kind of numeric behind the scenes. This part doesn't matter that much. I just wanted to point this out here because you're thinking, what kind of coordinate is Gen2? The reason why this is working here is because ggplot accepts that behind the scenes this will just be 1, 2, 3. In any case, this means that the Y coordinates is a species just like before. The X coordinate for each label should be different though. This means that the first label should be around here, the second one should be at the end of the second bar, and the third label should be at the end of the third bar. Luckily, we know that these positions correspond to the number that we have in our column n, so we put this in there. And now for the label, luckily we don't actually need to have something very elaborate here. We just reuse the same column here to use the numbers as labels as well. So we specify the label aesthetic as n. And now if we execute all of this, we get labels, but they're not very pretty. So let's start out by moving them on the x-axis a little bit. Maybe let's do -5. We'll just do the trick. Looks okay. Maybe -3. Yeah, this looks better now. But still they're hard to read. So let's make them larger. Let's set the size to, I don't know, 4 maybe. Maybe larger than that. Maybe 8. Oof, that's too large. Let's do 6 then, I guess. Yeah, but this looks good. But now we have to move this a little bit. Maybe even more. Maybe still a bit more. And now the labels are dark color on dark background. That's not very nice. So let's make this into white color and maybe make this bold. And while we're changing stuff like the colors and sizes, we might as well change the color of the bars here as well, because this gray is kind of depressing. So let's just go into our geom col layer, and in there we can specify that the colors are supposed to be, let's just reuse Dodger blue 4 here. And if we execute this, then we don't really get a nice blue bar. But I don't know if you have seen it, but the output actually changed. Let me just remove this part here and re-execute this. Notice how the outline of the bars changes. And the reason for that is that an object like geom col has actually 2 colors, the outline color and the fill color. So this is why we need to specify the fill aesthetic here and not the color aesthetic. And if we execute this, now things look much better. Okay, cool. We have added more information to our chart. Now let's think about our code a little bit here. Here we see that we have duplicated code again. We use the same data set in both layers. And the cool thing is that we don't need to do that. What we can do is just take this data set, put this in here, and then remove this part here. And if we execute this now, we get the exact same image, but we have nicer code because we don't have this part duplicated here. The reason why this works is because everything that is put into the first layer is just inherited to the other layers. And the same thing works with the mapping as well. Let me make some room here and then copy and paste the mapping from here. And we see that in both layers we actually have Y as species, so we could remove this part here and then leave that part in there. And this way we have the mapping that is common to all layers inside of the first layer, and everything that is specific to one layer in the separate layer. And that way we could also clean up our code here a little bit. And also we can remove a little bit of extra space here, because for one argument we don't need this. And now again, same output, just nicer code. Now that we have our code cleaning done, let's just make our histogram a little bit nicer. Let's just move this into a new code chunk. Let's revisit our chart from before. And now let us make our histogram more informative by splitting this up into different sexes maybe. Maybe the male penguins and the female penguins have a different distribution of weights. I suspect that is true, but we will never know unless we look at the data. So let's create one differently colored histogram for each sex. Remember, our dataset looks like this, and the information about the sex is encoded inside of this sex column. We see that there are also a couple of missing values. This is a bit unfortunate, and we'll see that in our chart, but we will just ignore this for this ggplot intro. And again, the way to use this column to make different colors inside of our charts is to specify the color aesthetic inside of the AES. So here we just map this to the sex column. And if we execute this, we see that we have made the exact same dumb mistake like before. We are plotting rectangles, and if we want to change the fill color, we actually need to change the fill aesthetic. I don't want to brag here, but I kind of saw this coming, but only because I have made this mistake 1,000 of times, and I don't want to convince anyone that I didn't do these kind of mistakes in the beginning when I started with ggplot. So this is why I made this here on purpose, so that you can feel better when you run into this problem when you're doing this yourself. Now, just like I mentioned, we see in our legend here that we have something for the missing values. Let's just ignore all of this part for now. What is more pressing here is that the histograms are kind of stacked. We have red colors in this area and we have these blue colors in this area, so there seems to be some difference between female and male penguins. But still, I would like to have histograms that are not stacked, but histograms that have a shared baseline. And there are two ways to fix all of that, and both ways lead us to two new concepts that are hugely important in ggplot. Let's start with the first one, which we can see when we look at the documentation of GM histogram, and we scroll down here and we see that we have something like position stack. Again, we see something like stat bin here. That's just because this is the natural partner for GM histogram. The position argument is the same for GM histogram too, so this is why I'm showing you this part here. Notice how the stuff that I explained with the stat thingy helps you understand what's going on in the documentation. You now know that you can just look at this position stack and it will probably mean the same thing for GM histogram. In the grammar of graphics, each layer has a position argument, just like any layer has a stat argument, each layer has a position argument. And now if we want to avoid stacking the histograms, we just have to modify the position argument. And here I don't want to set this to some string that says stack. I could set this to some string that says identity, but really what I want to do is to use one of those many position function helpers, because they all start with the name position and I can just scroll through them and don't have to remember what's the correct word. I scroll through them and see, position identity, that sounds like the right thing to do. So I use this and now things look different. But we have to be careful here because right now our histograms are on top of each other, so we have to make sure that we also change the transparency, the alpha value, to something of 50% transparency, for example, and now we can see more of the underlying histogram. Okay, so this was a really easy fix, just making sure that we change the position argument, and then depending on what we use in position, we might also have to use a little bit of transparency. Another position that you could try is using, and again, it's really helpful that we're using this position helper function here, because we can now scroll through this thing, and position dodge sounds like something which might be nice. Somehow the histograms dodge each other. Let's see how this looks. And if they dodge, we probably won't need the alpha anymore. And now, this is what dodging does. I wouldn't recommend using this here. This is still a bit cluttered, but really to understand what positioning does and what position dodge does here, it's really cool to just try this out. And there are other instances where you can use position changes too. For example, let's reconsider our point chart from before. This one here, let's just copy and paste this code. Let's just copy and paste it minus this ugly stuff that we put in there. And if we throw this in here, then we can revisit the chart from before. And now we could, for example, change the positioning of the points. So here is another position argument. As I said, each layer has that. And now we can use one of those position helpers. And here I want to use the jitter position. If I execute this, you see that my points moved a little bit. And now whenever I re-execute this, my points wiggle a little bit more. You see what this position jitter does is it wiggles at the coordinates of all of the points that we have plotted. This is sometimes very useful when you have stuff on top of each other. For example, if all of the values that are recorded are on a grid, then a lot of points will overlap way too much. And with GM jitter, you can make this more apparent. And this is a really common technique, which is why you could actually get away with not using the position argument and using geom jitter instead, which is just geom point with position set to jitter. Again, this is just a really helpful technique when points overlap too much. For example, we can look at this code here again and change the data set to the MPG data set. And then we could look at something like displacement and I don't know, CTY. And for the colors, we might use class here. And now we see that we have points all over the grid. So we can actually see those points, but we have used geom jitter here. Let's have a look how this might look if we had not jittered. Well, in this case, we have a fine grid with a lot of points that overlap each other. So this is a really classical use case for why you might want to use geom jitter sometimes to wiggle the points a little bit, just so you can be sure that you can actually see the data. Now coming back to our histogram from before, the one that has no position changes, this one here, I told you that there are two ways to fix this. One was the position change, we have covered this now. The other one is to give each sex its own window. And the way to do that is to add another layer on top of that and use one of the facet layers. Basically, a facet is a small window that is designed for parts that you use inside of the facet layer. What this means is that we could use, for example, facet wrap, and then we have to specify, okay, which aesthetic gets another window. So here we could use the sex variable again. So we write vars, we use this vars function and then stick sex in there. And then we get a nice little plot for each of those sexes. In that case, we could actually use theme and set legend position to none to get rid of the legend here because each window already comes with its own label. And in our code, you can see that we had to use some extra function here. And I could go into details here of why this is necessary, but really this just fulfills the same function as the AES call. When you want to refer to something that is contained in data, like the sex column, you will have to use an extra function here. So basically that's how you can think about this. Woof, we are nearing the end of our video, so let's put all of this together by creating a brand new chart combining all of the things that we have learned here. And for that, we are looking at data from the gapminder package, namely the gapminder dataset. It looks like this, and for a lot of countries in all of the continents, it has information about the life expectancy in a given year. There's also some information about the population and the GDP per capita. We will ignore those parts, and instead we will just create a nice visualizations from these columns here. So what we will do is to first pass this data to ggplot. Just like we've learned before, let me find out where this was. Here we can actually stick the data inside of the ggplot layer, and conveniently the argument that comes first in ggplot is the data layer. So a common thing to do is to pass your data set to the ggplot like so. And if you execute this, you get a blank canvas, but now the blank canvas kind of already knows our full data set. Time to specify some aesthetics. Here we specify our mapping by using the AES function, and then on the x-axis we use the year column that has information about the year. On the y-axis we just use the life expectancy, and then we also map the color to the continent. Actually, I should probably write out color. It actually works without this OR here. You can just abbreviate color and it will still work, but still I'm teaching a beginner's video here. I should do my best to type out all the things. And again, if I execute this, ggplot will fill the grid with all the information that we mapped, but without geometric objects, ggplot doesn't know what to do. So let's just throw in a lot of points using this information here. And here we see a scenario where all of the points are on one line, which makes this very hard to read, and using some jitter might actually help us a little bit. So instead of geom point, let us use the jitter layer to wiggle our points a little bit. Now that is still hard to read and there's a lot of overlap, so we might make the points a little bit transparent. That's maybe a little bit too much. Let's set this to 0.3 and then we can increase the size to say 2. Now we have a lot of points and it is hard to really distinguish all the different continents. Maybe it will help us if we throw in a line for each continent that will sort of show us the trend that the life expectancy had over the years for each continent. So what we could do is add another geom layer, in this case geom line, to, well, plot a line. And if we do that, we see that this is a mess. If we think about this, it might become clear why this is happening. Geom line is just a layer that draws lines from one point to the other. But really what I wanted to do, if I remove this part here, what I wanted to have here is to have one colored line for each continent that sort of fits to all of the points that we have here. And if we put it like this actually sounds like something like a statistical transformation. And that way we know, aha, we cannot use geom that will just do everything as is. We need to let ggplot know it should compute stuff and then draw a line from that. And the way to do that is to use the geom smooth layer. And now we get what we want. And ggplot is actually so nice and put some confidence bands around these lines here, and I'm pretty sure the statistical folks among you will find this very cool, but the other people will have no clue what this is doing here. So let's just remove this by setting SE to false. Don't worry, you don't have to know that you can remove it like this. I didn't cover this before. I just wanted to mention this here. Whenever you want to draw a smooth line, just set SE to false to remove this gray stuff that is around the lines. And while we're at it, we can also increase the line width. Let's just set this to 1.5 maybe. Line got a little bit bigger. We could also do 2. Let's just do 2. Make it a very big line. I might regret this later on and change it back, but for now, let's just go with line width 2. So we've got basic geoms here and we have the chart elements. Now let's make the overall thing look better. One of the first things we have learned is to use the minimal, where we increase the base size so that the fonts are nice. And then we can use the labs layer to modify our labels. For example, for the x-axis, we can actually remove the label and set it to element blank, because everyone will know that these are year labels. On the y-axis, we set this to life expectancy in years. And as a title, we use life expectancy increased over time. And of course, we should probably tell everyone where we got this data from. So we put this stuff into the caption. And now we have some nicer labels for our chart. This is already starting to look better, but the more I think about it, the more it annoys me that I cannot really differentiate the differently colored points. So really, I should give each continent its own window, and by now we know that this happens via the facet wrap layer, where we use this ominous vars function and just stick the variable that we want to use to make different windows in there. And in this case, this is the continent column from our dataset. And now we get a nice window for each continent, but I would like to have each continent on the same row so that I can compare them better. And if I look into the facet wrap documentation, there is something called nrow, which sounds like the number of rows. Let's check the documentation. It says number of rows. Okay, so cool. Let's just set this to 1. And this does indeed what I want. And just like last time when we used facet, we now notice that the continent legend is a little bit superfluous. So let's add a theme layer. And in there we can set legend position to none. Nice, now we have more room for our windows here. And actually, now that I see the points better, I might also decrease the transparency so that I can see the lines a little bit better here. Okay, now let's think about this. Let's have a look at what we can do in theme here. Maybe we can apply a couple of changes. And there's something called panel grid. So maybe let's just set this panel grid minor to element blank, maybe to just remove it, because right now there are really a lot of grid lines. That's a bit tedious. So let's just remove this and then set this to element blank, just like we did here in the labs layer. And then we have less grid lines, which makes this feel a little bit less cluttered, which is always good for a chart. And then finally, we should fix the axis labels here. Right now, the year labels are overlapping way too much, and that is because we have way too many labels here. But we've already learned that we can modify these things via the scale layers. In this case, this is scale x continuous. And we notice that via the breaks argument, we can set the labels that we actually want to look at, where we want to have a grid line. And in this case, let's just set this to the years 1960, 1980, and 2000. Nice. Now we have removed a couple of year labels, and now all of them that are still in the chart are legible. Yeah, this is pretty nice. I am satisfied with the chart. I think we can leave it like this, and with that we have made a decent chart, and we can see that in general the life expectancy increased for each continent, but for some there's a huge fluctuation for the countries, and overall some continents looked like they have a much higher life expectancy than other continents. So this begs the question, how can you continue learning ggplot? For starters, I would continue regularly in the Tidy Tuesday challenge. Just Google Tidy Tuesday to come to this GitHub repository. And then each week there is a new data set you can just open, for example, the last one. And this will give you access to some new data set. You can just take the code that you get here copy it, and then set this into your document, execute this, and then you have a new data set that you can play around with to learn how to wrangle data, or if you want to focus on ggplot specifically, just like we did in this video here, then you can try out some new chart type or try to learn more about ggplot. Just try out a couple of little things. And then when you're happy with the basics of ggplot and want to figure out how can you use ggplot to make really nice, insightful charts, then I have a course for you that you can check out. You can find it via the link in the description. It has tons of video material that you can look at to learn how you can implement the most important data viz principles with ggplot and how you can create lots of cool charts with lots of different chart types. Of course, you will find all of the code that we wrote today for free on my blog. The link for that is also in the description. And with that said, I hope you've enjoyed this video. Thank you for watching. Don't forget to hit that like button if you enjoyed this video, because it was a ton of work and the like would help me spread the word. So thank you for that, and I will see you next time.